he looked for other ways to fit the data, and then he got it right when he assumed that the planets don't move on circles, they move on ellipses. So he had the idea that the planet does not go around the sun on a circle, but on an ellipse. With the sun being one focus of the ellipse. That's now called Kepler's first law. His second law is that that's now called his second law, which says a planet sweeps out the same area in the same time. And what it means is that the planet goes slow here and speeds up here, and goes slow again and speeds up here. So when it's close to the sun, it's faster. So that got him the idea, the motion of the planets must have something to do with the sun. There must be something about the sun which makes the planets move. He thought that he could conclude that by the fact that they go faster when they are closer to the sun. And he was right. So what wasn't right was his explanation. He thought it was magnetic forces which attracted the sun and the planets. But the idea that there's a force was right. Galileo mathematics. His father didn't want him to. His father wanted him to be a physician because he thought he made more money with it. But then Galileo talked his father into letting him study mathematics, which was good. Galileo, as a young boy, once was in a service in a cathedral, and he was bored. He would watch the chandeliers swing. These cathedrals had open windows when there was wind, and the chandeliers would swing. And he thought that he observed that the time of swing was the same no matter how big the amplitude of the swinging chandelier was. And he had no way of timing it other than his pulse. Watches were not invented at that time. So he used his pulse to time the swing of the chandeliers, and he got fascinated by this, and he went home and built a pendulum, and he tried it out. And let me show you. If I find my about the same time, even though this one ball is much heavier than the other. So he started thinking about this. Why is this? Can this be true? And then he did this famous experiment, which he may never have done. It's a good story anyway. He went on to the tower of Pisa and dropped two cannonballs. One much heavier than the other. This one is light, this one is heavy. And they reached the floor at the same time. Aristotle had said, heavy body falls faster than the light one. It's not true. Galileo showed it's not true. Nobody ever had tried it out, strangely enough. Aristotle was such an authority that everybody believed it. Nobody tried it out. But Galileo tried it out, and there it was. It was true. A heavy body and a heavy object and a light objects fall at exactly the same rate. When you drop a feather and a piece of lead, you think the feather is slower, but it's because the feather has more resistance to the air. If you do this in a vacuum, you see that it's not the same. In fact, it falls the same. I have a feather and a piece of lead in here, and I pump the air out of this. The feather sticks there. Okay. It worked in the lab. So much for that. I tried it too many times this morning. Probably next time. But they go down the same rate. They reach bottom at the same time. Feather and a piece of lead. Then he started to do experiments with gravity over the falling bodies. And since he didn't have the timing device, this was too fast. He diluted gravity, and he did this by an inclined plane. So here's what he did. He let the ball, I'm going to do this once. Roll down, and he noted the time it took for the ball to roll down different distances. And he found out that the distances traveled by a body or an object in the same time are as the odd numbers beginning with 1. For example, when the ball rolls this distance in 1 second, in the next second it traverses 3 times that distance. In the following second it traverses 5 times that distance, and then 7 times, and so on. And he did this by having notches in here, and he was listening to the Let me show you this. I will bring this when he was sitting in the garden, and an apple fell on his head. And that's another one of those stories nobody knows if it's true or not, but it's a nice story. The apple fell on his head, and he started wondering,